Hello everyone, welcome to EduCell. In this video, we are going to discuss about optimal caching. Before going to start this video, I'll tell you why we are using this optimal caching. Just for a little knowledge, I will provide you. There is a cache, okay, cache memory used in our system, which helps the machine to perform well. Or the faster performances we are using cache. So in general, I can say this topic is based on computer organization or architecture topic, but we are using greedy approach. So that's why we are reading the optimal caching. It's a you can say one of the page replacement techniques. We'll discuss that. Don't worry, though it's a computer organization topic. I'll tell you the basics of it. Then we'll switch to how it is working. Okay. So as for the memory hierarchy, before going to the memory hierarchy, I must tell you, the memory helps us to store the data, and also it helps us whenever we need a data, we can fetch the data from the memory. Okay. So as for this, the memory could be defined as the categorical memories are there, like register memory, cache memory, main memory, and auxiliary memory. Auxiliary memory are sometimes called as secondary storage, like we have SSD or HDD, okay, like this. So these are called as secondary and auxiliary also, you can say, which are extra memory. And RAM is considered as main memory, random access memory. Cache memory is as usual, its name as cache memory. And registers are the smallest unit of memory is called as registers. Based on the working speed, the faster is register, slower is HDD or SSD. But comparatively, HDD and SSD, definitely we must say SSD is a faster. But still, though it's a secondary storage, so we must know this one. Okay. Now, uh, unit, the price is higher in case of register than cache. Like this, it is lowest. Like we know SSD we are using at a cost around some thousand, like or around 5,000, 4,000. It's a starting price for SSD. But you think if registers are more, definitely the price of the laptop or might the system is more. That's why whenever you're purchasing, you have to check how what is the cache size. Okay, so the higher cache size you are purchasing, the higher amount you are paying. So based on that also we decided, as also the storage capacity, the capacity is less, the smallest unit that we discussed. So register will store less memory. These are the introduction part. So this is important for us to know before going to the optimal caching. So we must say whenever we are saying the CPU, which is central processing unit, so it will not directly connected to our secondary storage. It will connect to a memory which is somehow smaller than the random access memory. I must say these are certain uh, you know pages. These are pages we must say, or virtual things, or a virtual memory we must say. Then the RAM is connected with SSD or SDD. This is our secondary storage. These are the structures, actually we should know this one. Okay, so these are, you can say, we can say these are frames. I must change the color of it. Our This is secondary storage. Secondary storage. This is primary storage, and this one is cache. Though cache is very small as compared to this primary and secondary, we know register is also there, but register capacity around some KB. It's not good that much. If we say within 1 KB we need to store it, it's not possible for us to store that one within certain KB. We may think of MBs. So it could start with the MB. It could start from the GB that we are having, like 8 GB, 16 GB, which are minimum for us in RAM. Okay. So in SSD, these are starting with the TB, which you can say it's a secondary storage SDD or SSD, and Cache is, the CPU is first asking the cache because there is no such connections you can find from CPU to RAM. If your mobile phone is there, so CPU to RAM is connected, but CPU to ROM is not directly connected. From RAM, we are giving the data to the CPU in case of mobile phones or smartphones or small devices. But in case of system or a laptop, first the CPU will ask the cache. Why? Because it is faster. Based on the working speed, it is fastest in nature. Okay, it will give in some nanosecond, okay, or might be in picosecond. It will provide you the answer, but in RAM it is comparatively slower in time. So definitely it's directly not asking the RAM, but the pages which we are saying as for the terms, I can say we are using here as page, okay, which is a virtual pages. We can say this one virtual pages. Here we can say frames, which is called as physical page. Okay, so we must know this. These are the terminologies which might be studied, or you may heard this term in operating system as well as in computer organization. Okay, our main target is, though we are contact with the cache, though the CPU is asking cache is very limited. So that's why we need to replace uh, you can say the stream or the data which is being asked by the CPU. We need to replace that. We will not letting CPU to know if we are actually connecting with cache. Why? Because we need to give it faster. Okay, though we need to give it a faster data, so performance could be faster. So we need high performances. We do not need the CPU should be idle. The CPU should wait for our data. If it is there, na, it will be hanged. So whenever we are getting hang, so we are pressing Control Alt Delete. In that case means we are removing one processes. It might be consumed somewhere. It might be consumed our primary memory. It might be facing issue due to some certain problems. So CPU cannot handle such things. So in that case, hanging could be there. So we do not want CPU should be hanged or CPU should be idle. To give the data as fast as possible, we are using cache. But how fast the data could be replaced? Suppose CPU is asking A, if A is not there, suppose B, C, D, E is there within that four pages. So what we have to do, which one to be removed in such a way that the CPU will get it immediately. Okay, you may change the first one, you may change the second one, third one. There are many approaches. But how we will give the faster data so that CPU will perform well, that is why we need the page replacement technique. Though we say each individuals are considered as one page, one, two, three, four. These are the pages. Okay. Within that, we are keeping the data, and we are not letting CPU to know that we have given the conditions or we have given the connections with cache. That is why we are introducing page replacement techniques. So in this page replacement technique, there are like MRU, LU, FIFO, and optimal caching. Out of this four, optimal caching will be studied. So that is why we need the introduction should be given. Why cache? Then what is cache? How cache will help? That should be known to you. Then only you can understand. And these are the boxes which are being there in secondary storage is called as frame, or you can say it's a physical page. You will read it in other chapters like computer organization and operating system, that will be discussed, but somehow we need some introduction why it is needed, so that is why I'm discussing with you. Next is we will discuss there are four methods or techniques for page replacement in CSHE, which is cache. Okay, so first one is first in first out, first in first out. Second one is LRU, least recently used. Okay. Third one is MRU, which is most recently used. Fourth one is optimal caching. I'm just saying that is OC, optimal caching. Okay. Or else you can say it's optimal cache replacement. Better I'm saying it is optimal cache replacement. Optimal cache replacement technique. Okay. Sometimes we can say it is furthest, furthest in future. What is this? We will also discuss that one too. Clear? So first of all, we should know why page replacement is important. That I told you here in this figure. So we know we have suppose A, B, C, D. These are four data we have. Suppose CPU is asking E. So we need to replace any data out of it. That the CPU will get immediately. How we will contact? So there will be a replacement technique in between RAM to cache. Only RAM and cache will discuss this one. And if the data is not available in RAM, so it will ask the HDD. Again, the page replacement will be done in RAM with the memory, like the secondary memory with the primary memory. So definitely secondary memory it should have the data. If it is not, so definitely CPU will answer the data is not available. Okay. So in this way we are just connecting with the theme first. Okay. Next, just an example is given. You can say a question is given to us. So as for the question, it is there using page replacement technique. Find the number of hits or misses, or you can say the faults. Fault and misses both are same. Hit will be like if we'll get the data immediately, we can say it's a hit. Otherwise, we can say it's a miss or misses. So where the page size is 4 means we have to create and the data streams are these are the data streams with the request done by the CPU and we have to provide the data. Okay. As for FIFO, we should run it. So here pages are 4. First, you create certain boxes where you can say the pages would be 4 means the maximum size of it is 1, 2, 3, and 4. Okay. So these are the things that we should have to write first. And here, as per the example, it is asking you about a number of page replacement. But in the exam, we might be answering only optimal caching. Okay. So like we may write the data on the above of it. So we must say if you are taking this data, okay, so 4 that will be first given as input. There was nothing in the cache. So we may write either from the bottom you can write from the bottom or you can write from the top. Okay, so it's up to you, but for me I'm thinking that we should start from the bottom of it. You can start from the top, not an issue. Top could be written and generally we are writing in the from the top to bottom, but you can do from the bottom to top also, not an issue. 4 then 3 because 3 is not there. By the way, first thing is you have to fill it. Okay, next 2 is not there and the space is available, you can write 2. Then for 1 you can write 1, 2, 3, then 4. Okay, this is said to be compulsory maze. Why? Because nothing is there, so I must say it is maze for us. Okay, which is said to be compulsory maze. Okay, I must say miss. That could be better. This miss is called as compulsory miss. Okay. Next, we have 7. Okay. So first come, first serve. Whichever is coming first, that will be replaced. So 4 was the first, then 4 will be replaced, and 3, 2, 1. The data is not there and CPU is asking, that is why page replacement is done. If the data is available, then we say there is a hit. If data is not available, we need to replace, means there is a miss. So here we can say it's a miss. But this is compulsory miss. Okay, but this is a miss, we can say, or fault. Compulsory miss or fault, I must say, miss or fault. Clear? So fault or miss, we must say this one if the data is not available in the CPU. Okay. Next is 8 is being asking, and 8 whether it is there or not. No, it is not there. So 7 is replaced. So the second one which is coming first, that will be replaced. Okay. Again we can say there is a miss. There is a miss. Clear? Next is, next data it is asking is 6. Whether 6 is there or not. Like I'm just writing this value as these are the data present inside the cache, and 6 has been asking. So here there is no 6, but which one will be removed then? The 2 will be the third one when the first come first serve. So the 2 was there, so 2 will be replaced then. 2 will be replaced and it will be written as 6. Though we are replacing, so miss we are writing, it's not hit then. Now the previous data is 1, 6, 8 and 7, and 1 is asking them. 1 is there, no need to worry. You can write it is heat. Okay, I must change the color of it. It is heat. Okay, means right now we got one heat only. Next is 4 is coming, and the data is 1, 6, 8, 7. As per the data, it is there, but 4 is not there. The 4 is not there. So the previously the updated one is 1. So that is why we are just updating it as 4. Next we must say it is a miss or fault. Okay. This is how we are doing the first in first out. And then LRU, which is least recently used. First of all, we need to maintain the pages. Then 4, to write the hit and miss. First of all, you have to write the data streams once again. 2, 1, 7, 8, 6, 1, 4, or sometimes what the people are doing, they are just taking one pages here, and above that they are writing the data streams. Okay, but I have not done this one. Sometimes also you may see, though it's a compulsory miss, so definitely they can be writing in such a way that like the first will be filled, then second will be filled here, that could be not be there. So third one. So in this way that also being written, not an issue. Or else you can give others are, well, you can say others are bracket, and you're just doing one by one entering of the values. Okay, clear? This is how we should maintain the 4 pages, means 4 different boxes inside the main box. Okay. Now We need to go for an arrow mark. Now we are entering this 4 now. Next 3, 4, 3. This arrow will help us to run this LRU. Next one, these are compulsory miss. 3, 4, clear. By default, this will be miss, not an issue. Whenever the 7 is coming, least recently will be changed. Whatever least we have used, you can check. Compare miss, this is miss, this is miss, this is miss, and this is miss. Now, which one to be removed and which one to be considered, that we have to check now. Here the 4 things have already been written. Now 7 came. So the least means the previously which was used, that will be deleted. Now we are just replacing this 7. You can check. 7 will be replaced, the 4 will be replaced to 7. Means this is least, means the previous used, then 2, then 1. Okay. So it is miss. Now another variable came, which is 8. If 8 came, previously the values are 3, 2, 1, and it is recently used, but least recently is 3, so 3 will be removed and 8 will be entered in place of 3. Clear? So now the it is miss also, because replacement is done, so we must say it is ended of this. Next, when we have 6 now, the least recently is 2, so that we have to remove. Then we may say, instead of 2 we may write 6. So here, as for the example, we have done the replacement, so that's why it is called as a miss, okay, or fault. I must say it is miss or fault. Okay. Next will be, when 1 will come into the picture, the data will be 1, 6, 8, 7. So when 1 will come, so in this case the least recently will be 1, so no need to change that one. Okay. So we must say there is a heat, so that heat will be considered in this color. It is heat. Okay. Because similar value will come in this case, the LRU will not work like FIFO. This time you may think FIFO and LRU there is no such changes. Definitely there will be changes. Suppose there are 1 1 1, suppose, okay, then the next will come, means in this one you are there, so definitely it will be considered as to be changed, so that will be there. But as for the example, it is running like this. Next 4 will come. Before that, for the data that we are having, the data that we are having is 1, 6, 8 and 7. So in this case 7 will be replaced by 4. Okay, previously 1 was replaced by 4. Then though it is recently used, so no need to change it. Now 7 will come into the picture and 7 will be replaced, because it is least recently used and a 1 we are used. That's why arrow mark will help you to run this program well. This is how the page replacement techniques are working. Now we'll discuss about the MRU technique. Okay, that I must say it is a miss. So heat is one. Here heat is. I'll change the color. First MRU, then MRU. Also we should maintain. I am keeping some gap for the data streams. The 4 pages means the 4 different boxes inside the page that we have to done. Okay, the data streams are 4, 3, 2, 1, 7, 7, 8, 6, 1, 4. Optimal caching also will write null caching. Okay, optimal caching also will discuss. Based on that also we will be writing the cache first. This is how we are doing the pages. Okay, now here also the same thing we will run, the same arrow. Okay, 4, 4, 3, then 3, 2, 4, and 1, 2, 3, 4. This will be done, right? Because this is compulsory miss for us. Next 7 is coming, 717 is coming. It is most recently used. So most means the 1 is there, so 1 will be replaced by this. Okay, next, though replacing the thing, so we must say it is miss, it is miss, it is miss. With the 4 are compulsory miss, and here also we are doing a misses again. Okay, next 8 came, so most recently used. Okay, now 8 came, so 8 will be replaced the 7 position. Here we can say the previous data would be 3 and 4. When 8 will come into the picture, most recently will be 7, so that is why that will be replaced. Okay, so where it is a part of cache miss. Okay, next will be uh, the previous data will be 2, 3, 4, and 6 came into the picture, so 8 was recently used. That is why instead of 8 that you have to write is 6, though you are doing the replacement, it is a part of cache miss or cache fault. Okay, next is the data will be like 1 though we are using, so here it was not previously there, so we need to replace it where, in place of 6. Okay, so 1, then 2, 3, then 4. Okay, it's a cache miss then. Next number or next data stream is 4. So here 4, though we were previously exchanged the data, so 4 is already there. 1, 2, 3, 4 is already there. So no need to worry because it's already there. So just change the arrow mark and keep all as it is. Okay, means the 4 is recently used and this is considered as heat. So heat is 1. Heat equal to 1 in this case, and these are considered as miss or or fault. Okay, so these are misses or faults that we found using the page replacement techniques. Next is optimal caching, then how it will work. In optimal caching, first of all, we have to check the future, whether in a future, whether we will work it or not. So farthest in future is considered here. Means in future whether you are using it or not. Like those data streams are 4, 3, the data streams I'm writing. Data streams are in different color I'm writing. 4, 3, 2, 1, 7, 8, 6, 1 and 4. Compulsory misses are always there in all the cases. 4, 4, then 3, then 2, 3, 4, 1, 2, 3, 4. These are compulsory misses. So we must change the color to green, which is a miss for us. Next is when 7, 8, 6, 1, 4 are coming, we have to check in future, is there any value we will be focusing, or is there any numbers or any data are there through which we can focus for the future. Here we found 4 could be used. I'm just changing the color. 4 could be used. Okay, 4 could be used and 1 could be used. Others are not, useful for us. Clear? So in that case, what we are doing, we will just replace, excluding the value 1 and 4, we will just replacing the values like 1 and 4 will be kept as it is because it will be there in future. That is why we are keeping this one, and 2, 3 are there. So you can replace any of this, not an issue, but 1 will be replaced. Suppose I'm replacing 7 there, better I'm replacing in place of 3. That could be a better format. So if I'm doing the replacement, so that is a part of cache miss. Okay, miss or fault. So these are considered as miss or fault. So again it will be a fault, and again it will be a fault. I'm just writing in the future. Now you can go for it. 1, 2, 7 and 4 is there. So you can replace, excluding 1 and 4, you can replace any of this, not an issue, because in future you will work on it. So 2 could be replaced as, because 6 is there. Now 2 you can replace. Okay. Sorry, 8 you can replace. Now second value is 8. So next one, 8, 7, 4 was there. 6 came. So anything could be changed, not an issue, but excluding 1 and 4. And others are considered as a hit. 8, 6 and 4 came. Changing the color. Okay, so here previously the data was 6. No need to change that one. 6, 8, 1, 4. When 1 came, it is hit. When 4 came, it is also hit. Yes, we are trying to grow the hit conditions, hit ratio you can say. So hit is 2 now. Okay. So here the hit is 1. Here hit is 1. Okay. This is what we are doing. Hit is 2 in optimal caching. Then your question could be, sir, can we use this in future, or can we implement it? I must say, though we are predicting, whenever CPU is asking, it will not ask you in future. It cannot be predicting by you that yes, definitely two could be used. It's a future. In future, what data will be asked by CPU, you cannot imagine that. But even if you cannot do a proper prediction, like accuracy is not there, 100% accuracy you cannot get, because anything could be asked by CPU. So in that case, what will happen? So it is the proper note. If I'll write note for the optimal caching is, we cannot, it is not practical, it is not practically implementable. Okay, we cannot can predict the future data stream asked by CPU. So optimal caching can't be implemented. Okay, so we cannot implement it, though we cannot predict in future. But how greedy is applying here? Here, you one by one, you are just predicting next value. We are just focusing on the future, farthest in future. From that, we are not replacing, and only the values which we found is getting updated. In this way, I think it is understood by you. So, if any problem, you can comment below. So, thank you for watching. Have a good day.